Hello and welcome to a new Voltlog. Today we are taking a look at yet another electronic load. I found this one on Aliexpress. I think it's a rather new model. Not many sellers have it. In fact, there is a single seller offering this product on Aliexpress, and that's it. You can't find it anywhere else. I can't say for sure this is the original version or not because, like I said, only one seller offering this product. And as we can see, it comes in this rather unexpected plastic protection packaging. It seems strange that they went to the trouble of vacuum forming a custom packaging for this dummy load. It must mean that they probably make quite a few of these. So inside the package you get a power adapter. I believe this was mentioned. Yep, it looks like one of those death adapters, like Big Clive would call one of these. You get some wires to connect to the load. This one looks interesting. Looks like you could connect to a USB port and test a USB charger, for example. And the dummy load itself, which is bigger than previous units we've had here, and the size is primarily given by the size of this massive heatsink. The load is advertised as 150 watts capable with a 200 volts 20 amp limit. Let's take a closer look at the construction. Starting from the top, looks like we have our DC input jack with 6 to 12 volts input. Next to that we have a micro USB female jack. I believe it's in parallel with the barrel jack, so you can power it through the micro USB. On this side we have a port which is labeled quick charge trigger in. So I think that while testing quick charge AC adapters, you need to plug in a device which is compatible with quick charge, just to enable the quick charge negotiation, so the charger will boost its voltage. Next we have our main high current input through these screw terminals. They look quite beefy. It seems to be missing the additional sense connection for the 4-wire measurement. That's not excellent for measurement accuracy. We have a second barrel jack. This one is in parallel with the main current input. It's for testing plug packs which have the barrel jack. And we also have a selection of USB female jacks. Here we have mini USB, micro USB and USB Type C. So these should be great for testing various phone chargers. The LCD sits nicely on this part of the board. We can see a couple of beefy current shunts in here. They are probably connected in parallel just to increase the current capability and the power dissipation. On this side we have a single tactile switch. It's nice that it's a large switch, and a couple of what look to be analog potentiometers. These are labeled coarse and fine adjustment. So it seems we get full analog controls on this dummy load. We have a buzzer. This will be used to signal the various conditions. And a 2-pin JST connector, which is labeled CTL. I don't know what this is for. Maybe we'll figure out later. On this side we also have a third barrel jack connector. I believe this one is connected with the input of the dummy load, and it certainly seems so by the tracks going through the main current input. But I believe it goes through the load through the current shunt. I believe the purpose is to place the load between a power source and a device, and the load will act as a multimeter to check the current voltage and the energy that will pass through the load. So lots of connections on this dummy load, but no PC connectivity, no data logging capability. It appears that perfect electronic load that we are all searching doesn't quite exist yet. But it would be nice to have one of these digital loads based on an STM32 microcontroller with open source software and hardware with data logging capability, at least 150 watts load capability with the possibility to upgrade, and a cost of roughly $30 shipped. Yeah, we don't quite have one of those yet. Before powering on, let's also take a quick look on the back. We see lots of plated through holes in this area where the MOSFET sits. These will help spread the heat between the different layers of the PCB, and will also allow air circulation from the fan. The MOSFET, as we can probably see, it's sandwiched between the PCB and the heatsink. I like this kind of construction. It's pretty well built, except for some nasty flux residue from all the manual soldering on these through-hole connections. But that's not such a big problem. I can clean that off later. Now let's turn the load on and see how it works and what it can do. I have my 12 volts DC power adapter here. So we get a welcome screen. Now we have nothing through the load, so it is measuring 0. Let's reset this counter. We can reset that by holding the button. Okay, so it went to 0. It looks like it was tested before shipping. By doing some short presses on the button, backlight on. Yeah, I don't want to turn off the backlight. Looks like we also have a Chinese menu. Yeah, so it looks like you can scroll through different screens that give you basically the same info but on a different layout. Doesn't look like you have a start-stop button, just this reset button, and the load will start working as soon as you adjust these potentiometers. This is basically a hybrid load. There is the circuit for an analog load where the current is controlled by the potentiometer, and there is a second digital circuit measuring current and voltage and driving the LCD, while at the same time being able to cut off the MOSFET when the values go over a preset threshold. So let's start using this load. I have these wires connected to my power supply, which is capable of 150 watts, so we'll be able to test the full power of this dummy load and see if it can withstand that. Let's increase the current. Okay, so the fan started working immediately. Let's go up to the full 150 watts. Okay, so the overpower protection kicked in. It seems like it cuts off for about 5 seconds, and then it redetects and it continuously cycles. Okay, so let's just decrease the current a bit. Okay, we are now at 123 watts. Let's try to change this screen. Let's get some other screen to see if the values. Yeah, I think I like this screen better. We are at 123 watts. So these are not your 10-turn pots. You have to adjust them very slightly and you already get an increase. I mean, yes, you can use this fine adjustment pot, but it's not the same as with a you can see it's very hard for me to set it at exactly 150 watts. Okay, so right now I'm very close to 150 watts dissipation into the load, and it seems to be withstanding well in terms of dissipated power. The temperature is at 60 degrees, and I did run a test earlier and it only went up to something like 70 degrees Celsius, and right here I'm in an ambient temperature of 26.7 degrees Celsius, so it's not bad. I think this load is really capable. You see, I think what's happening here is because the heat is rising, the properties of the MOSFET are changing, so the current increases through the MOSFET as it heats up. So I think that's triggering our overpower protection in here. Let me lower the current slightly. Yes, that's like a property of the MOSFET. Probably when the heat increases, its internal resistance goes down or something like that, so more current flows through the MOSFET. That's not ideal to have in an electronic dummy load, but it's a consequence of the analog dummy load with just a digital LCD added over. Because if this were a full digital dummy load, you would set, for example, your current or your power, and the dummy load will automatically adjust no matter what the working conditions are, will do its best to maintain that value that you set. But in this case, you set the current with a potentiometer, which is just a voltage that you set on the input of an op amp. But then if anything else changes in your circuit, like for example temperature rises, MOSFET properties changes, the current or the power will vary, will not be constant. So it's not ideal to have this in a dummy load. I was kind of expecting better than this. I was able to push the temperature up to 92 degrees Celsius by covering the fan. No over temperature protection kicked in up to that temperature. It might be there, it might be set to a higher temperature threshold, but I don't know, it doesn't look safe. If I were to design something like this, I would have it to throttle down when temperature reaches 80 degrees, for example, and completely cut off at 90 degrees, just to keep things safe. Granted, the fan was able to keep the temperature under 80 degrees Celsius while on full load at 150 watts. So if nothing bad happens, like a broken fan, you are safe, but you never know when the fan is going to break down. I've also tried disconnecting the fan and it doesn't detect that. It continues running even with no fan connected. So if you're planning to buy one of these and using it, I would keep it under supervision while using it. Don't leave it unattended. I've also found a setup menu on this load, and you can access that by holding the tactile switch while applying power to the load. So right now we are in the setup menu. If you hold the button again for more than 3 seconds, it will reset to factory defaults like this, and then it will start the load. To navigate through the menu, you do a short press and it will cycle through the different menu options for each press. To change one of the values, you do a double click and the value will start blinking. With each press of the button, it will adjust down by 1, or for each double press of the button, it will go up. Or if you keep the button pressed, it will go through the values faster. If you do nothing for 4 seconds, it will save that value. The first two options are calibration values for the amps and volts measurement. The way you do the calibration, and I figured this out by trial and error, you apply exactly 30 volts at the input and you adjust the load current to be exactly 10 amps measured with an ammeter. Then you double click the first option and it will record that value as 10 amps. Next, a single click, you go to the volts adjustment. Once again, you double click and it will take that value as 30 volts. Right now it's showing 0 because I have nothing connected, but it will work if you connect that. Unfortunately, I don't have a 30 volts 10 amps capable power supply here, and that will also cause the load to heat up very fast because it will have to dissipate 300 watts. You can also adjust the maximum voltage. You can also adjust the cutoff voltage here, although it's not very practical to access this menu anytime you want to adjust the cutoff voltage, and the load will continuously throw a voltage low error if you change this value to anything above 0. So it's not very practical to use this cutoff voltage. There is also a maximum current and this multiplication value in the menu. I'm not sure what this does. I could only get it to go down below 1. Maybe someone in the audience knows what this could be for. An important thing to note is that each time you reset to default values through that menu I showed you, all the calibration will go back to 0. So let's check what kind of measurement accuracy we're getting when the default values have been restored. The Fluke 87 is measuring voltage right at the input of the dummy load, and the MetroHit multimeter is measuring current on the low side. Okay, so right now the load is measuring 31.4 volts. The Fluke is measuring 31.39 volts, so that's quite good on the voltage measurement. On the current measurement, the load is measuring 1.96 amps, and the multimeter is measuring 1.97 amps. So quite a small error of maybe just 10 milliamps. It could be 5 milliamps because we don't have that extra digit in here. So I would say that's an acceptable error when we're talking about 2 amps being measured. That's like 0.25% error, which is acceptable in my opinion for this kind of instrument. I've also figured out what the small 2-pin GST connector is for. When a fault appears, like overpower or overcurrent for example, there will be a 3 volts high signal present on that connector to signal the alarm. The signal will last as long as the alarm, which is roughly 4 seconds. So you can connect an LED to that pin if you want, or use it to control something else. Now, to give you my final opinion on this load, first let's look at the positive things it offers. It can do full 150 watts power dissipation. It has good accuracy and the possibility of calibrating that. It has a nice display, all the info is visible at all time. And it has lots of input connectors for easy testing of the various adapters. Now let's also look at the list of negative things. There is no easy adjustment of cutoff voltage, and that's important for me. The load is not fully digital, it's not exactly constant current. We saw the power through the load increased slightly as the power went up, so there's no digital control to compensate for that. There is no over temperature protection. As we saw, the temperature went up to over 90 degrees Celsius, and I was measuring with my thermometer up to 100 degrees on the bottom side of the PCB. There is like a 10 degrees difference between what the load is measuring and what the case temperature of the MOSFET might be. And there is no PC connectivity or data logging function for this load, and that should be really useful for lots of people testing batteries, for example. So if you need one of the functions this load is missing, then it doesn't matter if it has all the other advantages, this load is not for you. But if you need to just dissipate up to 150 watts and get some on-screen logging of those numbers with some good accuracy, this might do the job just fine at just $29 with free shipping. It won't break the bank. It's certainly better than the previous 150 watt load that I reviewed, which was a fake product that would not meet the specifications, and it seems rather difficult to find the original version. But this load, it lacks some of the features I would like it to have. You could also upgrade to higher maximum power by using a beefier heatsink with 2 fans, because the load already has 2 fans connector, one on the front, one on the back. So you could do that. There is also a 180 watts rated load from the same seller being sold for $45, and the only difference seems to be a bigger heatsink with dual fans. So in the end, it all depends on what your needs are. It's up to you to decide if it's worth buying this. My job is done. I showed you what it can do and what it can't do, and there is a link in the description if you want to check it out. As always, thank you for watching this video. Don't forget to let me know what you think in the comment section, and maybe hit that like button because it really helps the channel. I'll see you soon.